All right, the last thing we're going to look at is some application problems. Really the only new thing, the thing about exponential application problems is that they might have this number in here, this number E, which you may or may not have encountered before. Kind of like how in geometry we have pi, right? Someone realized, hey, you know what? The ratio of the circumference to the diameter of a circle is 3.14159, blah, blah, blah. It's this same number no matter how big the circle is. So let's make a special symbol for that number since that number pops up a lot and we can actually use it. So they made pi. Same kind of thing here, all right? There was this number that popped up in certain math and science situations, certain business situations where they decided, well, let's just go ahead and, you know, make a symbol for that number so that we don't have to keep typing this entire irrational number every single time, which you wouldn't be able to do anyway because it never ends. So there's this number E, right? 2.718, blah, 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 to 12 decimal places. It actually never ends. Sometimes they'll round it and say, oh, just use 2.718, okay? And E, you should have an E button on your calculator. Maybe you don't. If you don't, you're just going to use the rounded version, okay? So the key here is that when you see an application problem and they give you an equation and it has E in it, you know that that's not a variable. That's not something you have to find. That's an actual number, okay? So for example, here we got, when a patient's given a 300 milligram dose of some drug intravenously, the amount C of the drug in the bloodstream T hours later is given by this function right here. All right, C of T equals 300 times e to the negative 0.3466 t. Okay, it looks complicated, but really it's just a matter of order of operations. You got a calculator, it's not really a big deal. How much of the drug is in the bloodstream after 3 hours? So like with any application problem, I always say, if they give you an equation, really your job is saying like, okay, what did they give me? Where do I plug it in, right? What am I looking for here? So they gave us T. They told us 3 hours. So, and they're asking for how much of the drug, right? And the amount of the drug is C is left. So we're looking for the amount of the drug when T equals 3. So the amount of the drug is going to be 300 times, and it says use 2.718 for E. If you just want to use the E button on your calculator, you can. If you don't have an E button, then just use 2.718 like they said. Raised to the negative 0.3466, and then instead of T, we're going to multiply by 3. Okay? Sorry for any shakiness. So at this point, really, the key, oh, let's say I have 2 negatives in there. The key is just to realize how to solve it order of operations wise. All right, make sure you're applying order of operations properly, and make sure that you're putting it into the calculator, okay? My issues that I usually have with students with these is they're not getting the same answer I am just because they're entering it into the calculator wrong, okay? If you have a big Mamma Jamma calculator like TI-84, 84 Plus, whatever, one of those, you could, using proper parentheses, put this entire thing in and get the right answer. If not, you're going to have to go in steps, all right? The first step would be to do negative 3.3466 times 3, because you've got to raise this to an exponent before you can multiply, right? PEMDAS. Got to do exponents before you multiply. Well, I got to know what this exponent is if I'm going to do it. So over here I got, let's see here, 2.718. See, I don't have the E on this, so 2.718. Oops, clear that. First I got to do the exponent. All right, so 0.3466, and it's a negative, all right, times 3 equals negative 1.0398. So I'm going to write that down. 300 times 2.718, and it's raised to now the negative 1.0398. So that's my exponent. So I'm going to come back over here and do 2.718. This little guy x to the y is going to allow me to raise a number to anything I want to, and I want to raise it to 1.0398. Yep. Negative, got to make that negative in there, equals that big long thing. Okay? So at this point, right? The last thing we have to do is multiply that number by 300. I'm going to go ahead and not clear this out. I'm going to keep this like this and just hit times 300, because the more you round, the less accurate your answer is going to be. So I'm going to hit times 300. And I'm going to get 106 points, and then, 069. So let's just go 106.1. 6.1 milligrams, because that's what we're looking for. How much is left in the system, which it seems like a reasonable answer, right? The longer a medication is in your system, as you go along, it's going to start decreasing, right? The longer you've had it in your system, the less you have in your system. So we started with 300. After 3 hours, we're only down to 106.1, so that makes sense. Okay, so the key to these problems really is just making sure you enter it in the calculator properly, right? And obviously recognizing that E is an actual number, not a variable. Okay, kind of knowing what that E is. I'm going to ask you to pause the video and try this one on your own, keeping in mind that it's another one of these year ones where they say x equals 0 corresponds to year 2000, and they're asking you for the year 2010. So that would mean your x would have to equal 10, right? 0 starting at 2000, 10 years later, so that would mean x equals 10. So they give you your equation. So go ahead and pause, and then when you're done, come back and check your answer. I'm going to go ahead and kind of write it out so that by the time you're done, let's see, so that'd be negative 0.036 times 10. Okay, so I would have to multiply this, and I'll get negative 0.36. I have to take 2.718, raise it to that negative 0.36, which should give me, I believe, 0.6977, some small number, and then finally multiply that by 436. If you've done it properly, you should get something like 304.0 something, 304.1 something, so it'll be 304.2.1 something in there, depending on if you use the rounded version or E. But, we're talking about cigarettes here, so I always say make sure your answer makes sense in the context of the problem. So we're looking at 304 billion cigarettes in the year 2010 will be consumed, because that's what they were asking about. Okay, if you've smoked 0.2 of a cigarette, you've still smoked a cigarette. So I'm just going to go ahead and round that baby up to a whole number. All right. And let's just take a second. I do have a summary at the end. If you want to pause and fill this out yourself, you can. I'm just going to talk about the answers a little bit, right? How is an exponential function different from a linear and a quadratic? Well, in an exponential function, your variable is actually in the exponent, right? And the graph is only headed in one direction. It's either increasing or it's decreasing, like a linear function. However, it doesn't form a line, right? It forms a curve, because you're not going up and down by this. You're not increasing or decreasing by a constant amount. You're increasing by an amount that's getting bigger and bigger and bigger as you go. Okay, so you're increasing more and more and more, or decreasing, more and more and more. Number 2, right? It would make most sense that 2 to the 0.5x would be b, because we have a positive exponent, so we're going to be increasing. And 2 to the negative 0.5x would be a, because with the negative exponent, we're going to be decreasing. Number 3 asks if either of these functions would have a y-intercept of 1. They actually both would, right? Because to find a y-intercept, you make x equals 0. And if we make x equals 0, right, then the whole exponent is going to become 0, because 0 times anything is 0. So both of those would have a y-intercept of 0, right? If it was 0.5 plus x, then it would not, right? Because we plug in 0 and we would get 0.5 plus 0. So the exponent would then be 0.5. So our y-intercept would be whatever 2 to the 0.5 would be, okay? And then finally, number 4, sketch a graph of f of x equals e to the x. I don't know how precise you were with this, but if we're just going to sketch a really rough graph, if we know a few things, for 1, our y-intercept is going to be 1, right? Because to the x, if x is 0, anything raised to the power of 0 is 1. E, we know, is some number, 2.718, blah, blah, blah. So it's like 2 point something, it's almost 3. So if we raise that to the power of 1, right, if that was e to the first, would be somewhere here, right? E to the negative first would be the reciprocal of that. So that would be 1 over 2, almost 3, so but somewhere between 1/2 and 1/3, so somewhere down in here, right? That's probably enough to kind of sketch a curve if you really wanted to get technical and do 2.718 to the squared, right? Make x equal 2. You could get something, you could get this point, probably be somewhere in there-ish, okay? But just kind of making sure you understand the properties of exponential functions enough to be able to sketch a rough graph, right? We know it's going to look like a curve that's increasing faster and faster. We know the y-intercept is going to be 1, and you know we can kind of get a point on each side.